we are going to discuss about velocity for rolling motion. Okay, velocity of rolling motion. So let's consider an object is on inclined plane. Okay, that is at the highest point. Okay, this may be a ring, a cylinder, or a sphere, so that it can roll. Okay, so without slipping it will rolls. So now what will be there? Downwards, weight is acting in this direction, mg sin theta will act upwards, normal force downwards, mg cos theta is getting acting, right? It is an angle theta. In this direction frictional force is acting. This is what we have seen in while finding kinetic energy, I mean acceleration, right? What is the acceleration what we found? So acceleration equal to g sin theta by 1 plus I by m r square. Okay, 1 plus I by m r square. This is what we found the acceleration, right? And what about the coefficient of friction? F equal to mu n. So from this acceleration we find the acceleration force. So from that we can find the normal force as well as coefficient of friction also. Okay, coefficient of friction. This is what we discussed in last class, right? Fine. Now we will find the velocity of it. We'll see now. So in this case, so this is an object and it is at a height h from the ground, and let's consider this total length is L and it is making an angle theta. Okay, so this is theta means this horizontal will be slope, so from that sin theta equal to opposite side by adjacent side, from this h equal to L sin theta. This is at this much height the object is there. Okay, in terms of theta angles. Okay, now it is coming downwards with velocity v. Okay, clear, right? So at this point, according to the conservation of energy, potential energy will be equal to the kinetic energy. Let's consider this is the point A. When it reaches to this point B, potential energy at point A will be totally converted into kinetic energy at point B, right? Or lose in potential energy equal to gain in kinetic energy according to conservation of energy, right? So what is the potential energy from there to here? It is coming mgh. What is the kinetic energy? Kinetic energy here, what kinetic energy is there? Two types of kinetic energies. What is there? Kinetic energy of translational plus kinetic energy of rotational. That is called rolling kinetic energy total. So that is translational kinetic energy plus rolling kinetic energy. So mgh equal to rotational translational. What is the translational formula? Half m v square plus rotational half I omega square, right? So from this I want to find what I am about to find. I want to find, tell me, guess it. Velocity we are about to find. That's what I told, no? So, so from this, how can I take? If you take mv square, um, so half mv square of 1 plus. Okay, let me write one more step here. Then after I will write that. So that is mgh equal to half you can take common, then mv square plus I omega square. Okay, so from this mgh equal to half of mv square plus mv square plus I is nothing but mk square, with radius of gyration mk square omega square. Okay, so again from this mgh equal to 1 by 2 of mv square plus mk square of v equal to r omega, relation between linear velocity and angular velocity. V equal to r omega, from this omega equal to v by r, so it is v square by r square. So here m gets cancelled, remaining gh equal to 1 by 2 of v square plus v square k square by r square. So can I take v square common here? So gh equal to v square by 2 of r square plus r square plus k square by r square. Okay, so we want to find v square, so 2 you can take this side, so 2gh equal to v square of r square plus k square by r square. So from this we want to find v square. So actually we need to find v, so v equal to root over 2gh by r square plus k square into r square. Okay, you can write like this, or this only will be written as v square of 1 plus k square by r square. You can keep like this also. So here k square by r square is called as proportionality constant, that is beta. It is a dimensionless quantity. Okay, it's a dimensionless quantity. So v equal to root over 2gh r square by r square plus k square also will be written. Here, if they ask you in terms of theta, then you know that h equal to L sin theta. You can replace that. So v equal to root over 2g L sin theta into r square by r square plus k square. If you want to write in terms of beta, then v equal to root over 2gl sin theta by 1 plus beta. Okay, this is the formula. V equal to root over 2gl sin theta of 1 plus theta. Okay, sorry, 1 plus beta. Clear now? Beta is nothing but k square by r square. This is about velocity. Now we'll see about time. So we are about to find the time. So how to find the time? Same thing. When it is moving from here to here, it will cover the distance. I have considered as length L, right? That slope is length L. So it starts from rest. Initial velocity is 0. Initial velocity is 0. It is coming downwards with an acceleration A. And to move from here to here, it has taken time t. So what's the formula? Basic formula is equal to ut plus half a t square, as the object is coming in straight line. So here what is the distance it traveled? L distance it traveled. Initial velocity 0. So that is 0. So remaining half into acceleration into t square. So from this 2L by A equal to t square. So t equal to root over 2L by A. Okay, clear? Right. Now this t equal to root over 2L by A. What is the acceleration we found? G sin theta by 1 plus I by m r square. Right? This is what we found before. So if you replace that here, 2L by G sin theta of sin theta by 1 plus m r square. Right? So okay, let me write as this 1 plus I by m r square. Okay, so from this t equal to root over 2L of 1 plus, so I by m r square by g sin theta, right? So from this t equal to root over 2L of 1 plus I is nothing but moment of inertia, that is mk square with respect to the gyration, mk square by m r square by g sin theta. Gets cancelled, then t equal to root over 2L of 1 plus k square by r square by g sin theta. Okay, so just before we discussed, k square by r square will be written as beta. So t equal to root over 2L by g sin theta into 1 plus beta. So this is time. Okay, clear? From this, 2 constant, length constant, g constant, sin theta. So it will 1 plus b. Time is directly proportional to the root over 1 plus beta. Time is directly proportional to the 1 plus beta. Okay, clear? For sliding bodies and all, this beta will be 0. So beta is there for only rolling bodies. For slipping bodies, beta will be 0, constant. Okay, at that time, if it is 0, it's constant. Now remaining what is there? T equal to root over 2L by G sin theta. Okay, clear? This is for slipping bodies. Clear now?